Now a function f of x is defined on the set of real numbers by f of x equal to 3 plus integral of 0 to x 1 plus sine t by 2 plus t square dt, and another quadratic polynomial g of x is defined as a plus bx plus cx square. And how is this polynomial? The values a, b, c has to be decided from three different conditions. First is g of 0 is same as f of 0. G dash 0 is same as f dash 0, and second derivative of g at 0 is second derivative of f at 0. Then we need to find the area between y equal to g of x with the line 5x minus 2y equal to 0. So the whole problem is to find the curve y equal to g of x. That means we have to identify the values of a, b and c. Once we get the curve g of x, we have the limitations, so it can be directly using definite integrals. We can calculate the area. So let's proceed to find the function g of x. So in order to get the values of a, b and c, we need f of 0, f dash 0 and f double dash 0. All three values are required. Now clearly we can calculate f of 0. That would be 3 plus integral 0 to 0. It would become 0. So it is 3 plus 0. So we got the value of f of 0. But apart from f of 0, we also need f dash 0. Now what happens when we differentiate this function both sides with respect to t? We get f dash x equal to 1 plus sine x by 2 plus x square, right? So once we have f dash x, can we calculate f dash 0? What will be the value of f dash 0? 1 plus sine 0, that is 1 by 2 plus 0, that is 2. So we got f dash 0 also. From f dash x, we also need f double dash 0. So for that, let's calculate f double dash x, that is the derivative of f dash x. It would be 2 plus x square times derivative of 1 plus sine x, that is cos x, minus 1 plus sine x times derivative of 2 plus x square, that is 2x, by 2 plus x square whole square. Once we have f double dash x, can we calculate f double dash 0? Yes. How much is f double dash 0? 2 plus 0 times cos 0, 1, that is 2, minus 1 plus sine 0 into 2 into 0, that is 0, by 2 plus 0 whole square, that is 4. So we get the value of f double dash 0 also as 2. Now we got f of 0, f dash 0 and f double dash 0. But these values of f of 0, f dash 0 and f double dash 0 must be same as that of g of 0, g dash 0 and g double dash. So let's consider the g of x also. How is g of x given? The function g of x is a quadratic a plus bx plus cx square. So therefore, what is g of 0? Yes, it is a. Similarly, what is g dash x? G dash x is derivative of a0. So b plus cx square derivative, that is 2cx. Once we have g dash x, can we identify what is g dash 0? Yes. This term becomes 0, remaining is b. Now what is g double dash x? The second derivative of this is 2c, which is a constant. So therefore, g double dash 0 would also be 2c, right? Given f of 0 must be equal to g of 0, and we know both the values. F of 0 is 3, must be equal to g of 0 a. So this gives us the variable a value. Also given f dash of 0 should be equal to g dash 0. F dash 0 is half, and this should be equal to g dash 0, that is b. So we got the value of b also. And similarly given f double dash 0 must be equal to g double dash 0, that is 1 by 2 must be equal to 2c, or c value is 1 by 4. Now that we have all the three values of a, b, c, can we identify the function g of x? Yes. How is g of x function now? G of x is a plus bx plus, so half x plus cx square, that is 1 by 4x square. This is a parabola, open upwards, right? Once we have g of x, finding the area is very simple. So this is the graph of y equal to 3 plus half x plus 1 by 4x square, and the line which is given to us is 5x minus 2y equal to 0. Now clearly we can observe the point of intersections of 5x minus 2y equal to 0 with y equal to 3 plus half x plus 1 by 4x square as 2, 5 and The other point of intersection would be 6, 15. Now what is the area of region required? The required region is the area bounded between the parabola, that is g of x, and the line. Therefore, the required area is integral 2 to 6. Now the straight line is lying above that of the parabola. So it would be 5x by 2 minus the parabola equation 3 plus half x plus 1 by 4 x square dx. So it's easy to calculate the integral once we identify how the curve and the line are placed, right? So this is integral 2 to 6 minus x square by 4 plus 2x minus 3 dx. It's a directly integrable function. So what would be the integral? Minus 1 by 4 times x cube by 3 plus x square minus 3x, the valuated between 2 to 6, which would be simply 8 by 3 square units. Let's verify which option is it satisfying. Yes, the area is 8 by 3 square units present at option A exactly suits the required answer, right?